Thank you. My name is Rob Saidman, and I lead the Arup Building Services team in Sydney. My Brisbane counterpart, Andy Bradley, is somewhere at the back of the room. He promised me he would be very likely to heckle through the presentation, so I hope he behaves himself. I was fortunate enough to lead Arup's input on One Central Park. We did the building services, which is mechanical, electrical, hydraulic and fire. We always do fire engineering, ESD, vertical transport, and specialist lighting. There's many stories to tell on this project, and I'm going to try and pick out just a few with the time we have, just to tell you some of the interesting ones. But as someone said before, it is really a story of collaboration. There are a number of great consultants on this project, and it really, the result of the team's efforts is what you'll see. So to give you a bit of context, just to start off with, just last week the federal government released its intergenerational report. It's the fourth one that they've done. I'm sure you've all read it. Fundamentally what it said was that there's going to be a very big change in demographic, but it also focused on the fact that in 2054 our population in Australia is going to reach about 40 million. So it really shows that our story in the next 35 years is going to be one of growth. And while short-term wise, some governments, some local governments aren't reflecting that, that's our long-term story. The Chief Executive of the Property Council of Australia, Ken Morrison, said, as a result of this, what's needed are better approaches to managing this growth to create prosperity, jobs and strong communities. So how do we manage this growth and do it in a sustainable manner to create vibrant and healthy communities? And at least part of the answer lies in this notion of urban renewal, which John mentioned before. And the idea resonates really well with Sydney. So it's just looking at the broader context here. Sydney is suffering in many ways from urban sprawl, significant low density. If it had the same density as London, Sydney would be shared with 58 million people. Not that I'm advocating that, but it is something to think about, that this need to bring people back into the city. So it does ask the question about what an urban habitat should look like, and what can we learn from other cities. Quite a stark example here in Kowloon, Hong Kong, of intensive use of space. But you have to start asking some questions about the urban community this creates. It's just pretty difficult to tell in terms of the architectural expression, but what about human needs, quality of space, amenity, daylight, privacy, all those things which make a healthy and vibrant community? And what should a sustainable urban project look like? And I think that was one of the big questions which this project tried to address. How do you create this inviting community within an urban context? And the main park, which is the central focus of the site, which you see here, it's publicly accessible at all times, and it occupies about 38% of the site. So it's a grand gesture back to the community. Everything from public art, street markets, restaurants, retail, as well as car share, cyclists and communal facilities, foster within Central Park and define it as an eco-village which provides a sustainable place for residents to live, work and connect. Mark's earlier image described it really well when you see some of the mixed use in the site, which is fundamental in creating a healthy community. So once we know that bringing people into the city is a good initiative, how can we design engineering systems in a way which takes it one step further? The mixed-use nature of the site is a real advantage and provides great opportunities to look at servicing in a different way. And what the team did was we looked at more holistically, if you like. How do you address energy, water and infrastructure? And the advantage of Central Park is its scale. So from a sustainability point of view, we're able to substantially reduce greenhouse gas emissions through the use of on-site gas-powered trigeneration systems for district power, heating and cooling. And with regards to water usage, all non-potable water needs are serviced through a combination of on-site rainwater capture and wastewater recycling. And these couple of images just show that concept. Now, actually, before I go to this slide, it was a real collaboration, this idea between the Institute for Sustainable Futures at UTS, Elton Consulting, WSP, and ourselves. So our role was to building this over, and we had to define all thermal profiles, the cooling profiles to define a base load, which would then be fed back into the buildings, back into the central plant design, which was undertaken by WSP. So there's a real story of collaboration to optimise the size of the plant. In terms of water, what you see there is the water treatment plant, and it's a 1 megalitre per day plant, so it's truly immense. Constructed to meet all of the non-potable water demands of the precinct. It carries out sewer mining as well to ensure an adequate supply of black water to meet the precinct demand. And capacity also exists to feed off-site customers. The facility is known as Central Park Water. It's wholly owned in a boot scheme arrangement by Flow Systems. And upon completion of the precinct, because it's a staged thing, it will service approximately 4,000 residents and more than 15,000 workers and visitors daily. So the water balance is shown there, and it does show that there is a net positive contribution of water. So we've got our 1 megalitre per day, and obviously our big users are the cooling towers, which you can see at the bottom of it here. But the production more than offsets the needs. The water sources that are brought into the plant include rainwater from roofs, stormwater from impermeable surfaces, sewage from an adjacent public sewer, sewage of course from all buildings, and irrigation water from green walls themselves. The central thermal plant includes a 2.2 megawatt electrical tri-generation system, produces 13 megawatts of hot water and 21 megawatts of chilled water for the whole precinct. It uses natural gas to supply low carbon electricity, heating, hot water and air conditioning, as well as domestic hot water across the site. It was sized using that base load information I mentioned before, and the end result is a 190,000 tonne reduction in the site's greenhouse gas emissions, which equates over the 25-year life, which equates to about removing 2,500 cars off the road each year over the 25-year period. Now, what this did was, and that's an image that gets us mechanical engineers excited, so apologies for that, but it drove certain chilled water and heating water decisions within buildings. So conventionally in residential, you would do VRV or package units, but here we really wanted to use as much of that chilled and heating water as we could, so the design was predicated on chilled water fan cool units. It was set up in a 4-pipe arrangement within each apartment in a day-night configuration to encourage sustainable operation. And to further reduce pipe infrastructure, we consolidated the hot water heating circuits as well as the domestic hot water circuits into one. The water schematic on the screen just shows some of the energy transfer stations that you see at the bottom, which are essentially a heat exchanger which connects to the central plant, and then a group of pumping stations. And while it looks simple enough in terms of just having heat exchangers at the bottom of the building, there was a lot of thought that was put into how they would be configured to match the titling and the stratums above for ease of metering, which was a very important component of the design. We proved up the apartments using Revit, and this was back in 2009, 2010. It was required to confirm that tight coordination that Matt alluded to before, the 3050 floor to floor. And our reticulation for ventilation was all vertical. Nivelles obviously weren't too keen on having louvers at the side edge, so a lot of the reticulation was vertical, but it did have the advantage of removing those pollutants right at the top of the building for kitchen exhaust and toilet exhaust, but with it a number of coordination challenges. So the central thermal plant approach dictates certain things in terms of metering. Obviously heavily metered throughout the site to allow billing to take place. So traditional square meter pro rata billing approach wasn't really good enough, and it wasn't seen to be equitable. So all of the fan cool units had electrical meters to determine as a proxy the amount of consumption of each of the units, and it was used for billing. The approach here at One Central Park was taken one step further in that each apartment was equipped with real-time monitoring. So owners could tap a button and see how much electricity they've consumed on a real-time basis. Likewise for cold and hot water. And that form of demand management and giving the owners that empowerment to understand their own usage is a very important thing and quite unique for a development of this scale. So that's just an image there of the heat rejection of the central thermal plant. One advantage was that all could be consolidated, which removes a lot of the clutter from the top of the buildings. But how do you rate a building or development like this was the question that we had to struggle with. Frasers had made a commitment for 5-star Green Star when 5-star Green Star for a precinct didn't really exist. So the answer lay in intensive collaboration between ourselves, WSP and the Green Building Council. We had to go through about 100 credit interpretation requests. And we essentially redefined the tool so that it could apportion the benefit of the central elements to each of the buildings above. So you can imagine the central thermal plant was attributed to carbon intensity, which was then applied to all the buildings. But we had to go through that for every component of the park. We had credit interpretations around the appliances as well. And the outcome was an achievement of a 5-star multi-unit residential design, and hopefully very soon an as-built rating will be achieved as well, very close to submitting that rating. And for anyone who's tried this on a high-rise tower, you'll know how difficult this is. There are no 6-star rated buildings at the moment, and One Central Park is the only true high-rise tower that's achieved that accolade. So who's this chap? This is Patrick Blanc, the man with the green thumb, and he's not just dressing up there. He arrived at every meeting, green hair, green shirt, green trousers, and spray-painted green shoes. Needless to say, there was never a dull meeting with Patrick. One of the things he always said was that it's common in nature for plants to grow on steep habitats without soil, so why not bring them to the city? This was his inspiration in collaboration with Atelier Jean Nouvel. We aimed to have a tapestry of greenery and colour all along the building. So what are the engineering or sustainability merits of green wall? They can have multiple knock-on benefits. One of the main ones is just protecting building fabric and providing insulation from harsh UV radiation. They also filter pollutants and clear out CO2 prior to introduction into the building. But the sort of the intangible things are a big plus. That connection to the outside, that, if you remember that image I put up before of Kowloon, having that contact to the environment is such a positive thing. The other one there at the bottom is helping combat UHI effect. That's the heat island effect, and it's this phenomenon that our cities are much warmer environments than rural areas. And there's studies which have shown for every degree increase relates in warm environments, it can relate to about a 5% increase in carbon emissions or energy consumption. So to be able to reduce that through greenery is a positive thing. We estimated that the greenery reduces our peak loads within the apartments by between 20 and 40%, depending on the location of the apartment. And the image that you see at the top there is some intensive daylight analysis to assess the levels of radiation all around the building throughout the year, and that was fed back to Patrick Blanc to Aspect to determine the species to place at different parts of the building. Fortunately, it was able to be successful. And there's the reality. One of my favourite bits, which isn't spoken about that much, is the facade and this popping in and out of the development, which I think is beautiful. It was an absolute nightmare to model. We had to model the thermal comfort of every single one of the apartments, which was quite challenging, but it did allow us to optimise the performance of each of them and the facade performance, and not to mention all the other challenges in terms of locating sprinkler, pipe work, and getting the set downs to work. The other bit that I'll chat to is, I'm mindful of time, so I'm just whizzing along, is the reflector and the lighting theme which happens in the evening. So it was inspired by a chap called Jan Kassal, who collaborates quite a bit with Atelier Jean Nouvel. And our team did the implementation of that specialist lighting. So by night, the reflector showcased an artwork that features the performance of Darling Harbour during different seasons. And this was the image which showed the inspiration. And this is the implementation. So what it actually is within each of those 320 reflectors, there are 9 1-watt colour-changing LED nodes. And the total power consumption of that whole grid is 2.88 kilowatts, which is about 2 to 3 hairdryers, depending on what brand of hairdryer you use, which is pretty low. And it was part of this idea that we had an energy budget to play with, which was driven by the Green Star rating we were targeting. So we had to be conscious of all of our energy uses. impressive outcome. So just reflecting really quickly on some of the things in summary which make up a sustainable design and some of the issues that confront us typically in residential design. One is materials. I know I haven't touched on that in detail, but a lot of effort was put into material selection, the extent of recycled content, responsibly sourced timber, low VOC paints and the like. A real focus on reducing water and energy demand. That's been done by careful appliance and fitting selections. All of them are best-in-class WELS rating and energy rating. Automatic occupancy controls to minimise air conditioning, lighting. I've already spoken about the real-time smart metering. Even to the extent of the use of that non-potable water is used in the clothes washers to try and really maximise its usage. And last of all, the high-performance facade, as I said before. A lot of effort was put into the design of this loggia space, which acts as a thermal buffer to the apartments adjacent and really allows tenants to have that amenity of dual functionality, so it can be an inside or an outside space. And I think that amenity is the biggest part for me, that the fact that you have all these uses surrounding you, that creates a sustainable community which really defines this project. So thank you very much. I'll pass back to Mark to finish off.